One optional definition that I want to talk about. So this is a definition that I would encourage you to think about this as much as you can, because you need to kind of come up with some examples, and I'll talk about some examples in a second. But I want to talk about what are called limit points or accumulation points. So this goes back to that same definition of isolated points, boundary points, interior points, and so on. But a point C in the complex plane is an isolated, is an accumulation point of our set G. So a point is going to be called an accumulation point of G if the following. So if every open disk centered at C contains some point of G other than C itself. It's possible that the point C is not actually even in G, in which case everything is fine. But even if C is in G, then we still want it to, we still require that the set G is contained in every disk centered at C. So here's what I mean. If you were to take a point, if you were to take a set like this, so G is this set, which is this kind of, this little piece that's not open, that's not closed, plus this point. This point is an isolated point and therefore not an accumulation point. Accumulation points require that every open disk around this point, every open disk contains some point in G other than the center itself, okay, other than this point where it's centered. The way I like to think about accumulation points is actually, forget about the complex numbers for a second, but just think about the set E, which is going to be 1 over n, where n is a, say, positive integer. And this is, we're going to think of this as a subset of R, okay? Or if you want to, you can think of this as a subset of the complex numbers, just where all the imaginary parts are 0. That's fine. And so this is going to be the set 1, 1/2, 1/3, 1/4, and so on. And so if you were to graph this, what would happen is all these points are in the interval from 0 to 1. You'd end up with 1, 1/2, 1/3, 1/4, 1/5, and so on. And there would be infinitely many points. And if you zoom in, I mean, I'm clearly not going to be able to draw it, but if you zoom in, you're going to get arbitrarily close to this point 0, but you're never going to get there, and you're certainly never going to exceed this point, because the quantity 1 over n is always positive. So that means that it always stays to the right of that, of this line, okay? But despite 0 not being in the set, 0 is an accumulation point of E. It doesn't matter whether, I could even change the definition of E and include 0 in it. It doesn't matter. E is still called an accumulation point of E. And the reason is that zoom in really far to that point 0. So zoom in really, really far. It doesn't matter how small of an open neighborhood you take, you're going to intersect every open ball centered at this point is going to contain some point in our set. Okay, no matter how small it is, there's going to be some point in that set. Okay, and so that's what makes this an accumulation point. Accumulation points, it turns out, are exactly the types of points where, so if you want to talk about quantities like this, which we will shortly in a formal way, if you want to talk about the limit of f of x as x approaches a has to be an accumulation point of the domain of f. Okay, and so that's really where accumulation points come up. We will talk about, I will try to word things in the limit section so that you don't really formally have to think about accumulation points, but that's what accumulation points are.